All right, back to some related rate problems. You've been doing a few. I'm going to give you a few more. So let's look at this. So I've got sand falling off a conveyor belt. So it's falling into a pile, and the pile is making a cone. All right, and this is the volume of a cone. You need to know that. Okay, so it's like, the bottom is round. All right, so this is the rate that it's falling, and by looking at the units, you can tell that that's volume. So that's dV over dt is 10 cubic feet per minute. Okay, the diameter of the base is approximately 3 times the altitude. Okay, so the diameter is 3h. All right, at what rate is the height of the pile changing? So you know that means find dH dt when the pile is 15 feet high. So when h equals 15. Again, save that till after the derivative. All right, so let's get the equation down. So volume is 1/3 pi r squared h. So I make mention here about getting rid of extra variables. So let's take a look at what we've got. So I know I've got V and H as my given and find rates. So V and H are the two letters I want in my equation. I also have an R here. I need to get rid of R before I take the derivative. So this is going to help me to get rid of R. So you know diameter is 2 radius. So if I solve for R, I get R is 3/2 h. So let's go substitute that in. So I have 3h over 2 squared times h. Definitely fix this before you go take a derivative, because otherwise you've just got a lot of product rule, chain rule, bunches of stuff. So let's go fix it. So I have pi over 3. This gives me 9h squared over 4 times another h. So simplifying this, I get pi over 12, right? One of those threes cancel. Oh, not pi over 12, sorry. Let me fix that. So one of the threes cancels. So I get a 3 pi over 4 h cubed. Okay, now I have the two letters in my equation in my find and given rates. Now I want to go take the derivative with respect to t. So dv dt, carry along the 3 pi over 4, 3h squared, dh dt. Now I'm going to use my information given. So dv dt is 10. So I have 9 pi over 4. H I know is 15. I'm going to square it and divide through. So I have 4 times 10, 9 pi, 15 squared is dh dt. And I'm just going to leave it like that. All right, let's do one more. So I have this 10-foot ladder. You've been here before. That's the good one fixed number you want in your equation. The bottom of the ladder is sliding away from the wall at 1 foot per second. So again, put the x there. dx dt is 1. How fast is the angle that's between the ladder and the ground changing? So the ladder and the ground angle, there it is right there. So find d theta dt, and then when the bottom of the ladder is 6 feet from the wall, when x is 6. So I need an equation, not Pythagorean theorem, that's going to have x and theta in it. And by looking at this, I see a nice triangle. Oops. So I see cosine of theta is adjacent over hypotenuse. So I know that this is the same thing as saying 1/10 times x. So now I'm going to take the derivative with respect to t. And I get 1/10, and derivative of x is just dx dt. So now I'm going to use my information. Dx dt is 1, so I get 1/10 here. D theta dt is what I'm trying to find. Oh, sine of theta. I didn't get information about sine, but now I can use this when information. So if I can put in x equals 6 here, do you think I can find out what sine of theta is from this triangle? I think I can. I think I can find out what this side is, right? So I have 100 equals 36 plus y squared. So that means this must be y squared must be 64. So y is equal to 8. Good using good old Pythagorean theorem material. Get rid of that. So then I know that sine of theta from my triangle is y over 10, and y is equal to 8. So I get 8 over 10 for sine of theta. So d theta over dt is equal to -1/8.